Welcome to The Explainer. Today, we are diving into something huge. It's a new 40-year roadmap for one of the most ambitious projects in human history, the quest to create the ultimate map of reality. So, let's get right into it.
You know, at the end of the day, it all comes down to this one question. It's the question that drives everything. For centuries, it has pushed us to explore the absolute fundamental building blocks of our universe and the very rules that govern our existence.
Okay, so to understand where we're going, we first have to know where we are. Our current understanding of the universe, our best guide, is called the Standard Model. And it's been stunningly successful, but as you're about to see, it's also profoundly incomplete.
I mean, make no mistake, the Standard Model is one of science's greatest triumphs. It lays out all the fundamental particles and the forces that control how they interact with each other. It's basically the instruction manual for the reality we see and experience every single day.
And this table here kind of categorizes everything we know. You've got your matter particles, right? The quarks and electrons that make up you, me, and everything we see. Then you have the force carriers, like photons, which are particles of light. And finally, in a class all by itself, you have the Higgs boson, the particle that gives other particles their mass. It really is like a cosmic periodic table.
But here's the thing, if you look at those incredible old maps from the Age of Exploration, they always had blank spots, right? Areas marked with "Here be dragons." Well, our beautiful, intricate map of physics, it's no different. It has these vast, mysterious territories that are still completely unexplored.
So what are these mysteries? Well, these are the giant questions that are pushing physicists to their absolute limits. They're the puzzles that the Standard Model, for all of its incredible success, just can't solve.
So get this, just take the masses of the particles we do know. They span more than 12 orders of magnitude. That's a 1 with 12 zeros after it. And we have no clear explanation for this wild pattern. It's kind of like finding a dog, an ant, and a blue whale in the same family tree and having no clue how they're related.
And the questions just keep coming. Why is there more matter than antimatter in the universe? And maybe the biggest question of all, what in the world makes up the 95% of the cosmos that we call dark matter and dark energy? We can't see it, we can't touch it, but we know its gravity is shaping everything. And on these points, the Standard Model is completely silent.
So how do you even begin to explore these unknown realms? I mean, you can't just send a satellite. You have to build new, unbelievably powerful tools, machines designed to literally recreate the conditions of the early universe and let us peek behind the curtain of reality.
Now, right at the heart of this whole quest is the Higgs boson. It's the simplest, yet probably the most puzzling particle we've ever discovered. You see, all other fundamental particles have this property called spin. Think of it as a kind of tiny built-in rotation, but the Higgs has zero. It doesn't spin. And this unique kind of placid nature makes it the perfect tool to probe the universe's deepest mysteries.
The strategy then is to shift from discovery to precision. The Large Hadron Collider, that was a discovery machine. Its whole job was to find the Higgs, and it did. The next step is something called a Higgs factory. It's a precision machine designed to measure the Higgs's properties with just incredible accuracy. And why? Because even a tiny deviation from what the Standard Model predicts, that could be the single thread that lets us unravel a whole new theory of physics.
And scientists are dreaming even bigger. They're also planning even more ambitious projects, like a muon collider. Muons are unstable particles, and smashing them together would be incredibly powerful. But it's a massive technological challenge. It's really a high-risk, high-reward gamble on the future of physics, pushing the absolute boundaries of what we can even imagine building.
Now, something this monumental, a quest this big, it's not something one country can do alone. This isn't a race. It's more like a global fellowship of scientists, all pooling their resources and their brainpower to tackle problems that are just too big for any single nation to solve.
And it is truly global. I mean, today, nearly 100 nations are actively engaged in particle physics research. From CERN in Switzerland to Fermilab in the US and Keck in Japan, this has become one of humanity's largest and most collaborative scientific efforts ever.
Just look at this survey of over 3,000 physicists. It shows you the sheer breadth of this collaboration. You can see about 37% are focused on the energy frontier, the big colliders. But so many others are tackling the problem from completely different angles: the cosmic frontier with telescopes, the super weird neutrino frontier, and of course, pure theory. It's a full-on, multi-pronged attack on the unknown.
Okay, so this is really important.
This quest for knowledge, it's not just some abstract thing. The journey to understand the universe brings totally unexpected but incredible benefits to all of us, right here on Earth.
The spin-offs from this fundamental research have literally changed the world. The particle accelerators built to smash atoms, they're now used in hospitals for cancer therapy. The need for thousands of scientists to share massive amounts of data, that led directly to the invention of the World Wide Web. The detectors designed to see invisible particles, they gave us the PET scanners that save lives every day.
And this quote from the report, it just makes the connection so incredibly personal. One of the very scientists writing this roadmap for the future was, at that exact same time, receiving life-saving cancer treatment using technology that came directly from this field of research. That's just a powerful, undeniable link between pure curiosity and real-world impact.
So where is this all heading? Well, the report dares to cast a vision 40 years into the future. It predicts a world where our current standard model is just one small piece of a much grander, more unified picture of reality. A world where today's greatest mysteries are solved, and we're grappling with fascinating new ones we can't even imagine yet.
You know, this quest to complete the map of reality just reminds us that our drive to explore is unstoppable. It not only reveals the secrets of the cosmos, but in doing so, it reshapes our own world. The next big breakthrough, the next World Wide Web, it might just be waiting to be discovered inside the next great particle accelerator.